In this topic, we'll discuss about the intercepts of rational functions. Okay, an intercept of rational function is a point where the graph of the rational function intersects the x or y axis. How to solve for intercepts of rational function? So to find for the x-intercept, substitute 0 for y and solve for x. Then to find the y-intercept, substitute 0 for x and solve for y or f of x. Note that not all functions have x and y intercepts. If the rational function has no real solutions, then it does not have intercepts. For those who have not yet subscribed in my channel, please subscribe for more updates. Okay, thank you. Okay, problem number 1. Find the x and y intercepts of f of x equals x plus 2 over x minus 5. So first, we need to find for the x-intercept. We have x-intercept, therefore, let y equal to 0. So just simply, we have y equals x plus 2 over x minus 5. So instead of using y, we're going to substitute 0 for that. So 0, we can have x plus 2 over x minus 5. So what we're going to do next? We're going to cross multiply. We have 0, no? 0 times x minus 5. So 0 times x minus 5 equals x plus 2. Then we can have, so 0 therefore is x plus 2. Then what is the final answer for that? We can have x therefore is negative 2. So the x-intercept is at negative 2 of x. How about for the y-intercept? So very simple, y-intercept, we can have x equals to 0. So make use again, y therefore is x plus 2 over x minus 5. Instead of using x, we can substitute 0 for that. So therefore we can have 0 plus 2 over 0 minus 5. Therefore y is negative 2 over 5. So our y-intercept is at negative 2 over 5 of y. Or easily you can have that one, the constant, no? That is 2 over negative 5. Okay, so that is the technique. It's because you have your 0 for x, 0 for x, so you can have 2 over negative 5. So that is the x and the y intercept of problem number 1. Okay, problem number 2. Find the x and y intercepts of f of x equals x squared plus 5x plus 6 over x squared minus x minus 6. So we need to factor out first for the numerator and denominator. So we have x squared, that is x and x, 6. Within the two numbers, if we're going to multiply, the result is 6. And then if we're going to sum up, the result is 5. So we can have 3 and positive 2, no? Or we can have 2 and 3 or 3 and 2. Okay, how about in the denominator, x negative 6? We can have also that one, 3 and 2. But then if we're going to add, the result must be negative 1. So negative 3, positive 2. Considering the numerator and denominator, there is a common, so you can cancel out x plus 2 in the numerator and also x plus 2 in the denominator. So we can have now y therefore is x plus 3 over x minus 3. So find for x-intercept. So y therefore is 0. So 0 equals x plus 3 over x minus 3. So cross multiply, you have 0. Therefore, we can have x plus 3. So therefore, the x-intercept is at negative 3. Okay. How about for the y-intercept? For the y-intercept, we have x equal to 0. We have therefore, then x plus 3. Then we can have x minus 3. So make use of the value of x, that is 0. So 0 plus 3 over 0 minus 3. Therefore, y is 3 over negative 3, or we can have that negative 1. So therefore, the y-intercept is at negative 1 of y. So that is the solution for problem number 2. Okay, problem number 3, we can have determine the x and y intercepts of f of x equals x squared minus 9 over x squared minus 16. So find first for the x-intercept. So our y therefore is 0. So we can have y equals to x squared minus 9 all over x squared minus 16. So we can cross multiply. That is, our y is 0. So 0, therefore x squared minus 16 equals x squared minus 9. Okay, so cancel out, you have 0 for that. That is x squared minus 9. So factor out. So 0 therefore is, we have x, then negative 9, so that is negative 3, positive 3, or positive 3, negative 3. So therefore our x, we can have positive 3, and then we can have negative 3. So the x-intercept is at negative 3 and positive 3. No? How about for the y-intercept? So our x is 0. So we can have y therefore is, so x squared minus 9 all over x squared minus 16. So y therefore, instead of using x, we can have 0. So 0 squared minus 9 all over 0 squared minus 16. No? This is 9. So y therefore is negative, that is positive. So 9 over 16. So that is for the y-intercept. So at 9 over 16. So that is the solution for problem number 3. Okay, problem number 4, determine the x and y intercepts of f of x equals x squared plus 4 over x plus 2. So first we need to find for x-intercept. So let y equal to 0. So we have y therefore equals x squared plus 4 all over x plus 2. So instead of using the value of y, or y, substitute that to 0. So 0 therefore equals x squared plus 4 all over x plus 2. Then cross multiply to 0, therefore x plus 2 equals x squared plus 4. So this is now 0, so we can have x squared plus 4. Okay, so to solve for that, we can have x squared plus 4 equal to 0. Then we have x squared equals to negative 4. Extract the square root both sides. We have square root of x squared, we can have x. Then square root of negative 4, we can have plus minus negative 4. Since negative 4 has no real solutions, therefore we can conclude that no x-intercept. Okay, how about for the y-intercept? For the y-intercept, let x equal to 0. We can have y therefore equals x squared plus 4 all over x plus 2. So y is simply 0 squared plus 4 all over 0 plus 2. Y therefore is 4 over 2. That is positive 2. That is no, the y-intercept or y-intercept is at positive 2 of y. Okay, that is the solution for problem number 4.